Today we're going to be talking about medians, altitudes, and midsegments. So let's start with medians. A median of a triangle is a segment whose endpoints are the vertex of a triangle and the midpoint of the opposite side. The point of concurrency of the medians of a triangle is what we call the centroid of the triangle. The centroid, which you can see here in red, is always inside the triangle. The centroid is also called the center of gravity because it's the point where the triangular region will balance. So, for instance, if you had a very long pole and wanted to balance a very large triangle on top of it, you would need to find the centroid because that is the center of balance for it. Now let's talk a little bit more about centroids because you may not know this, but the centroid of a triangle is located at 2/3 of the distance from each vertex to the midpoint of the opposite side. So what that means is if we actually looked at this triangle right here, what we would notice is if the whole median was 39, that's the distance from the vertex to the midpoint. The distance from the vertex to the centroid is 2/3 of that distance. So if this was 39, 2/3 of that is 26. The distance from the centroid to the midpoint is 1/3, or 13. An easy way to make sure that we can tell this is by looking at the actual original triangle and making sure we understand that. So to be clear, the 26 would be the equivalent of this part right here in our original triangle. The 13 would be the equivalent of this section right here. Now let's talk about altitudes. An altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. Please notice here it says line, not line segment, meaning this is the opposite side. The line contains it, goes on forever in both directions. And that's because, as you can see right here, in an obtuse triangle, this altitude ends up going outside of the triangle. Every triangle actually has 3 altitudes. You can already see the second altitude ends up being inside, and then the third is also out. That's because if I rotated, this could be my base, and if this was my base, this would be the height, or the altitude. And if this was my base, this would be my height, or altitude. An altitude can be inside, outside, or on the triangle. The point of concurrency for altitudes is what we call the orthocenter of the triangle. So you might notice right now we don't have a point of concurrency. These 3 are not meeting. So let's pull this back a bit and see if we can find a point of concurrency. So in an obtuse triangle, the point of concurrency will not actually be where we see the altitudes, but we have to continue these lines out a bit like this. And we'll find that the orthocenter ends up being out and about right over here. On a right triangle, it becomes very easy because 2 of the 3 are going to actually be on the triangle. So this is an altitude, and if we turned it 90 degrees where this was the base, this would be an altitude. If this third line, the hypotenuse, is the base, then we will have an interior altitude like this. Finally, in an acute triangle, as you can see, the altitude will end up being on the inside of the triangle, like this, meeting right here. All right, so now let's talk a little bit about midsegments. You might be wondering, Mr. Peacock, what's a midsegment? And that's what this section's for. A midsegment of a triangle is a segment that joins the midpoints of 2 sides of the triangle. Every triangle actually has 3 midsegments, which form the midsegment triangle. But let's first talk about this. So if you look, this midsegment right here is formed by these 2 midpoints. If you look, the 2 midpoints that are there are 2 of the 3 sides. The third side, the one that is not included, is going to be parallel and double the midsegment. Here's what it looks like, by the way, when we have 2 other midsegments. This is the midsegment triangle right here. The midsegment of a triangle is parallel to the non-included side of the triangle, and its length is half the length of that side. I do want to also add, these are now going to be parallel lines, which means, for instance, if we had this angle right here, this degree would be the same as this degree. We actually end up creating 1, 2, 3, 4 congruent, similar triangles to our larger original. You know, what's interesting about midsegments is there is actually in popular culture an example of a midsegment that we know. And there he is right now. It's the Triforce. And with that, thank you very much for listening. Please like, subscribe, share, all that jazz, or don't. Have a good day.